Hello, welcome everybody.
Hey,
We're going to give just a few seconds here for people to continue joining, but I see we already have a number of people here, so thank you for coming. So we really do appreciate all you being here, and I'm pretty excited about the presentation today. We're going to be talking about optimize to thrive, maintenance strategies that work. But before we dive into the webinar, let's review a few ways you all can participate during the webinar.
all right, hold on. Sorry.
It's okay.
Uh-oh. What is it doing? Oh, there we go. Okay. There we go.
So, yeah, throughout the webinar, if you have any questions, you can type them into the questions feature. You can see that's highlighted in this little picture here. And then if you want to comment or participate in the conversation we're having, sometimes we ask questions. You can type those into the chat. You see the little chat icon there. And then we will be asking audience questions. So we do appreciate your participation in those. And then also at the end, we're going to have time for a Q&A. And I'll be looking in the questions icon for any questions that have been posted throughout the webinar so we can address those towards the end. Okay, so we do this every time, but let's practice using the chat feature. So everybody that's here in the chat, let us know where you are joining us from. And then I am...
Oh, I know Cody very well. Cody Krieger.
Yep. And I'm in Eugene, Oregon. Brian, where are you at in Baltimore?
I'm in Maryland, yeah.
Maryland, okay.
Bunch of people: Arizona, Mexico, Toronto, California, Carolinas, Bethlehem, Pennsylvania, right up the road from me. Oregon, Delaware, really close to me.
There's like so many people from Oregon in here. I'm really surprised.
It's because you're from Oregon. Mexico, Ohio. And sorry, everybody, my dog is like super upset at somebody outside. I don't know what it is. Can you hear me?
Sorry, everyone, my refrigerator's making noises.
Colombia, Arkansas.
India, Michigan. So not Kenya. Yeah. So not only the US, but worldwide, you guys. We have a lot of customers and people in our community that are located all over the world.
Pakistan, Trinidad, do you know Sonia Mathura? She's an upkeep ambassador from Trinidad and Tobago. And DC, right down the road. Well, like an hour, 15 minutes from me.
Just a 30-minute tram ride or something.
Well, from
what are those called? Train.
From Baltimore.
Oh yeah.
Oh my God, Frankie is driving.
Okay.
Can you hear?
Well, thank you all for commenting on where you're located. We're very glad you're here, but now it's time to get started with the webinar. So I'm happy to introduce the speakers today, which is myself and Brian. Brian, do you want to give a little introduction of yourself and tell people about your background?
Sure. So I am currently in the midst of fighting off some sort of virus, so just bear with me on my brain fog. But I've been a director of maintenance and reliability. I've been a heavy equipment mechanic. I was a GSE flight deck troubleshooter, all types of things, from executive maintenance leadership to being a mechanic, everything. So go ahead, Missa.
Okay. Thanks, Brian. So yeah, I'm the senior marketing manager here at Upkeep. I've been with Upkeep for over 2.5 years now. I actually got my certified maintenance and reliability professional certification through SMRP last year. I was able to do that through taking Reliability X courses, and I read, if you guys know who Ramesh Jalati is, but I read his book about maintenance and reliability best practices, and that's what helped me pass that exam. Also, earlier in my working career, I worked as a manufacturing technician in a semiconductor plant. And so I do have a little bit of hands-on experience knowing what it's like from an operator standpoint. I've never done maintenance in that environment, but I do remember when I had assets that I was operating and they had downtime, it was a pretty big deal. So I have a little bit of understanding of how that stuff works. And then for today's webinar, first we're going to dive into an overview of why maintenance strategies are important, We'll talk about some common challenges, and then we'll dive into understanding failures in maintenance and the FMEA process, which is failure modes, effects, and analysis process. And then we're going to review different optimized maintenance strategies and then how to integrate some of those strategies into a reliability-centered maintenance. We will have time at the end for Q&A, like I said, so make sure you're submitting your questions throughout the webinar as they come up. So maintenance optimization involves understanding how and why equipment fails. And it's about selecting the most effective maintenance strategies and integrating those strategies into a cohesive maintenance program. It's important to have a maintenance strategy because you're going to have better asset reliability and more uptime versus downtime. It can improve cost and cost control. It improves safety. You get more equipment longevity. It can help you with regulatory compliance, operational efficiency, and then, of course, with the data you get, you can make way better, more informed decisions when it comes to your maintenance. And then next, we'll talk about some of the common challenges to implementing an optimized maintenance strategy. Some of the things that we hear and we know are resistance to change is a big one, poor communication, lack of leadership support. That is like hard. That's a hard one to overcome. Brian, what are some of the challenges you've encountered in your career when trying to get these maintenance strategy going?
So the biggest one by far is a poor design, is purchasing machines and not understanding the operational context that they will be living in, and not sizing them appropriately for capacity, the way they're operated, things like that, right? But that's a huge one. Everything starts there. But, lack of leadership is huge. People who don't understand that, things need to be maintained to a certain strategy. And, maintaining is not just going and looking at a machine every 2 weeks. There's a whole different thing. There's so much more to it than that. And those are the things that we really want to try to talk about today.
Yeah. Okay. So now that we've talked about that a little bit, can you go back to the last slide, Brian?
Sorry, yeah.
We just want to hear from all of you. What are some of your challenges when trying to kind of get a maintenance strategy, maintenance program going at your organization?
Mike was ahead of the curve, all of the above.
Yeah. They may be what's listed here. Maybe there's some other things that we don't have listed here.
Funding.
Yep.
Big one. Yeah.
Mm-hmm. I think with funding, you have to
leadership.
Yeah, you have to make the case for funding, right? You have to say, here's what we're spending now. Here's where doing the strategy would save us X and make the maintenance team X more productive. That can be tough.
Training and knowledge and adequate training.
Poor quality of data is a big one. It's really hard to make good decisions when you don't actually have good data.
Well, yeah, I mean, there's all of these things compound together and they all lead into, trying to get leadership support. And maintenance professionals aren't always the most savvy business communicators, right? So a lot of that goes into how we communicate, the data that we drive, and the realities of how the plant is actually functioning, and then tying those things to the strategy that you're trying to push.
Yeah. Well, we have one person that says just not even having a strategy, even coming up with one.
Yeah, right? You're not alone. There's a lot of organizations that don't have a strategy, right? It's just fix it when it breaks or look at it every so often, right?
So more of a reactive maintenance strategy, right?
Sure. Or just a very, very fundamental preventive maintenance strategy that's not driving real value.
Yeah. Okay. Cool. All right. Well, let's jump into understanding equipment failure and maintenance. We're going to talk about this because this is going to lead into how to create and determine which maintenance strategies are going to be best for you and how to optimize those. So let's jump in.
All right. I will take over from here. So we're going to talk a little bit about understanding failures in maintenance. So when we talk about machine failures, again, we're generalizing here, top things, not every single thing. So you're going to experience lots of different failure modes. So we have wear and tear, which is super common, right? Those are the replaceable items, the things, the deterioration over time, bearing seals, gears, gaskets, belts, liners, all that stuff. And then we have fatigue. Fatigue is due to cyclic loading, right? So if we're not operating things correctly, or we're overloading, we're trying to push that machine past its capacity, things like that. Corrosion is huge. A lot of us work outside. Water is you can't get rid of it. It's just what it is, right? There's all different types of corrosion. You could be generating corrosion failures by not having things grounded correctly, or using dissimilar metals in fabrication and in the way you're building things. So keep those things in mind. Overloading is another one. Overloading leads to fatigue and compounds wear and tear. So we want to make sure we're operating things within their design capacities. And then operator error. This is a huge one. No amount of preventive maintenance or corrective maintenance or condition-based maintenance is going to solve poor operation of a machine. There's training is the only thing that takes that out of the equation, or you design it in such a way where the operator does not have that much impact on the failure modes from operator error. So again, there's tons of these. You guys have all your own, but these are 5 real big ones that cover like a broad range of failure modes.
Brian, correct me if I'm wrong, but I believe, isn't operator error like the largest percentage of common failures?
Yeah, outside of poor. Well, yes. Operator error is a massive contributing factor to failure modes, because a lot of times we like to trade away tomorrow's reliability for today's production, right? Yeah. Remember that line. That's a super important line.
Yeah.
Okay. I wanted to add this. Everybody on here probably knows the bathtub curve, right? But this is an association. It's just a visualization of failure, right? So the very fundamental of the bathtub curve is our infant mortality, right? That's the initial, when a machine or a part or something is set into motion for the first time, it actually has a higher failure rate than it does in the next, which is your constant failure rate and or random failures, right? And then that's through the majority of its life cycle. And then you have your increasing failure rate towards the end, which is your wear out. So I wanted to show this so that it can be visualized, so you can see that when you're purchasing new machines, or you have machines that are already in a state of random failure or constant failure rate, and then if you have machines towards the end of their life cycle where they're increasing failure rate and they're in a wear out stage. So this is a good visualization of failure and how it is represented across the life or time of an asset. So, okay. Let's get into talking about failure modes and effects analysis. FMEA. Everyone's heard that term. It's more difficult to do right than most would understand, and a lot of people don't do it, and that's okay with certain things. But we're going to talk about some ways this can be done, and where and when to do it that's the most effective. Okay, so what is failure modes and effects analysis, right? FMEA is a proactive tool used to systematically identify potential failure modes. So we're assessing the impacts on the system, whether it's a component, a part, whatever. We ought to know the severity of the failure, the likelihood of its occurrence, and its detectability. The detectability is a big part that is often overlooked. How accurately and how and what kind of timeline can you detect a potential failure mode, right? That matters. And then, of course, FMEA is used in all different types of industries. Every single one you can think of has probably utilized it at some point. Okay, so what's step one? Step one is a system breakdown, right? We want to begin by breaking down systems into their components and subsystems. Each component is then analyzed individually for potential failure mode. So we're taking let's just say a pump skid, right? It's got an electric motor, a pump, and some pipes, and a distribution box or something, right? We're going to take that, we're going to break it down to the individual components, and then we're going to further assess what things could be impacted there. So this is system breakdown. We're going to make things small, take them down. We're going to analyze small things from a big thing, right? Step 2 is we want to start identifying the failure modes, right? What possible ways could it fail? How could operating conditions and environmental factors and their interactions with other components potentially cause a failure? So if our electric motor, for our example, our electric motor is belt driven driving a pump, well, how could the alignment of the pump and the motor interact with the belt life, right? How could the tension of that belt affect the shaft end bearing or on the motor or on the pump? Do we have the proper foundation? Do we have resonance control? Do we have pipe strain control? Are we using a VFD on this motor, right? So there's all these things. We're looking at all the potential failure modes that could impact these individual components. And then we want to analyze the effects of failure. What will happen if one of these things fails, or if it experiences some sort of fatigue or corrosion or types of failures that we have? What will it do? What's the severity? What's the consequence, right? And we start to rank these things. Okay, so if the belt stops, we just lose flow, not a big deal, we replace the belt. Oh, but if the pump blows apart, we might send impeller material downstream into our valves, or if the motor burns up, it could overspeed the pump, or, I'm making things up here, but you guys get what I'm saying, right? We want to identify those hazards and what are the losses associated and the risk associated with those effects. And here's an important one, right? We want to assign an RPN, so risk priority number. So we're evaluating, we're evaluating the likelihood of occurrence, severity of the failure, and the ability to detect that failure. Each factor is given in a numerical rating, and the product of these ratings gives the risk priority number. High RPNs indicate critical modes that require immediate action. So those would be the things that we really, really got to pay attention to when we look at our RPN matrix. I forgot to put a picture in here of one, but I'm sure you guys have seen them. It's a heat map that shows numbering systems in varying angles and kind of shows where that severity based on what we would call high probability, high impact, high probability, low impact, low probability, low impact, and low probability, high impact. So those are those 4 functions that you're going to find in that risk priority number. All right. And then, of course, we want to develop mitigation strategies. When we identify those high priority failure modes, we want to have a strategy to mitigate that risk. This may include redesigning the component, bingo, adding redundancy. Also, we talk about series and parallel reliability in design, right? Implementing condition monitoring, just in maintenance schedule. So all of those things are perfectly acceptable with the way you've identified the criticality and the severity and the detectability of these types of failures. So remember, there's no right or wrong way for your mitigation strategy as long as it is addressing the failure mode, right? Mm-hmm. Okay, review and update. Just like a CMMS, it doesn't mean anything unless we have the data, the documentation to be reviewed, to be leveraged, to maybe push along later on when we start changing a design, or we buy a new machine that we want to have the designs of the failures we've been experiencing, want to have new design changes implemented into that. Joseph says, an extremely tedious process. Yes, it is, Joseph. It really is, and that's why a lot of people don't do it. But I'm going to give you a hint here after this as to when it should be done. And Mike said, yeah, it helps setting up. Yeah, 100%. All PMs, all of them, should be directed at some form of failure mechanism, mode, risk, whatever. It shouldn't just be look at pump, right? So yeah, awesome. Thank you. Design. I made sure I put this in here. Failure modes and effects analysis is best used in the design phase, and it sets the operational capacity and strategy and the overall life cycle reliability of that machine. So if you're performing failure modes and effects analysis on a vendor's machine that they're trying to sell you, say, hey, I want to see your FMEA on this machine, or hey, you're going to let us do our own on this machine, right? Because once that design is set, what you've got, you're not going to get more reliability out of that machine that is inherent in its design. So if you conduct these proactive measures in that design phase, your operational capacity will be more in line with the way that the operation actually conducts its business. Your maintenance strategy will be addressing the only known things from that design, and then your overall life cycle reliability will be longer, right? You'll have a much more reliable asset because it was designed with intention first. Okay, let's talk a little bit about maintenance strategies. Reliability-centered maintenance. Everybody's heard of RCM. RCM is a methodology, right? It's the comprehensive approach that ensures maintenance activities are aligned with operational needs of the equipment. So we focus on preserving systems function rather than simply maintaining equipment on a fixed schedule. It seeks to determine the most effective maintenance strategy based on the criticality of equipment and its failure modes. So we are using machine context and the way that machines fail and the risk associated with them to then perform maintenance. So here's the overview of the process, right? We want to define our system's boundaries, clearly define the scope of the system or equipment to be analyzed. So if you're using production lines and you want to view that entire production line as one living asset, well, that's what you would be defining. If you want it, is it just one machine? Then that's also what you would be defining, right? So we define that first. Then we need to identify functions and functional failures, determine the primary and secondary function of systems and identify how these functions can fail, just like in failure modes and effects analysis. What is the function of this thing? What does it mean when it loses its function? What does that look like? So I'll use an example of a bearing. A bearing can fail technically, right? But still function. So that's why we have failures and we have functional failures, right? So the failure is the bearing has failed and it's, it needs to be replaced. A functional failure would be the cage blows out of the bearing, the shaft stops, or it's no longer able to perform its function. Identify failure modes. Again, same thing. We want to understand each potential failure, understand how it fails, and then assess the consequences of that failure. Select the maintenance tasks that are going to address those failure modes to mitigate them or shift the risk. And then we need to implement and monitor. Same thing. We want to have that feedback loop to understand where we've made these changes and then have it to continuously monitor the effectiveness of that. And then if we need to change our operating conditions or we need to add new technology, those things will be available for us because we've documented and tracked all the types of functions that we've been working to understand. Okay. Condition-based maintenance. So condition-based maintenance is a maintenance strategy that relies on real-time data to assess the condition of equipment and understand when maintenance is needed. CBM reduces unnecessary maintenance activities by only performing maintenance when there is evidence of a potential failure. This goes back to cost effectiveness, right? So if we're looking at if we're going up on the roof and looking at an HVAC unit every day, and it takes an hour to inspect the HVAC unit, we never find anything wrong. We should probably look at changing that or eliminating that service altogether and getting into some form of condition-based maintenance where we go, okay, we're going to monitor the current on the compressor. And when we see current rise or temperature or whatever, then we're going to go and we're going to start intervening and starting to assess machines, right? So we want the machine essentially to tell us its condition, how it's operating, and then we make informed decisions on how we're going to inspect it, maintain it, repair it. Condition-based maintenance is super huge. It's awesome. And you can do it visually and with a human as well. It doesn't have to be sensor-based. So if you just have specific inspections that are very pointed criteria, inspection criteria to assess wear, to assess limits, go, no go, you can also do the same thing. Okay, so key components, right? So condition monitoring tools, everybody knows these. These are like the talk of the town nowadays in maintenance world. Vibration, oil, thermography, ultrasonic, right? They provide insight into the context and health of the equipment. And we're looking for early signs of wear, failure modes, things that are coming out of alignment, you're losing function, stuff like that, right? The PNF interval, I don't have a picture of it, but the PNF interval has been modified several times to show condition-based techniques and where they fall on that failure curve. So you guys can check that out on your own time. Data collection analysis, right? We rely on continuous and periodic data collection from sensors, monitoring systems, right? It's allowing us to trend things. It's allowing us to look back at history and find patterns so we can start recognizing failures and accordingly. And then again, decision-making, right? If you have constantly sending guys in the middle of the night for weird alarms on machines and things, and you start looking at condition-based maintenance, you start to find, oh, okay, What are the thresholds? What is the operating context? Do we have the appropriate triggers? Do we have the appropriate tasks in place to understand and make good decisions on behalf of that asset and our people? And then the integration of analytics. I don't like the word predictive. I must have missed that when we were writing this. But advanced CBM strategies integrate that analytics and machine learning algorithms to improve accuracy of failure prediction. So you can leverage some pretty heavy systems that look at, all the data that's coming in, that's streaming in from these types of systems, and analyze them, and then kind of single them out to show you what are the most prevalent, what are the highest rates, and things like that. Preventive maintenance, super huge. It's the most fundamental way of having a maintenance department. Is you want a proactive strategy involves regular scheduled maintenance tasks, right? Prevent failure. We want to minimize the risk associated with failure, but we want to make sure that preventive maintenance tasks are cost effective with that risk, right? Key aspects of preventive maintenance. Scheduled inspections, we talked about that. That's the very, very basic, right? We inspect X 2 weeks, every day, every 5 hours, whatever. And we do replacement of parts. We're going to get in there and say, hey, every couple days we replace this thing. We make adjustments, we do calibrations, and we document everything, of course. But here's the big one: is balancing the cost and the risk. Preventive maintenance must be carefully planned to balance the cost of maintenance activities with the risk of equipment failure. Over maintenance can be costly, while under maintenance increases the risk of unexpected failures. Now, here's a caveat to that. Over maintenance can also cause more variables in the process, because we as humans are the biggest variable in the maintenance department, especially when we don't have proper maintenance tasks and checklists, and we don't have documentation that tells us what right looks like and what wrong looks like, and how to decipher between the two of those things. So the more you touch something, the more likely you are to induce a human failure mode into that system. So we don't want to touch things a lot, and we don't want to touch things too little. We want to find that fine balance between the cost effectiveness of that maintenance strategy and the risk associated with it. Run to failure. People will say, and I've heard this a million times, you can't run to failure. Where all we do is run to failure. It's terrible. It's terrible. No, the reason it's terrible is because you're running to failure on critical things. You're running to failure on things that matter a lot. It's okay to run to failure on machines, as long as that strategy is applied to non-critical things, and the cost of downtime or the cost of doing maintenance doesn't make sense for that machine. So when if you have what we would call low probability, low impact failure modes, failure strategy with that asset, run to failure, right? If it's not a big deal, it's not going to hurt anything, don't spend time maintaining it, right? But you guys have to do your own assessments internally to understand those things. But it's not a bad thing. I've had assets on the waterfront that we ran to failure. They were low criticality. It didn't matter. I'm not sending a guy on the pier out on a tugboat to get to the pier to fix this one thing, right? So that's how it works. So here are the considerations for run to failure. I kind of alluded to them. The applicability, right, is suitable for equipment non-critical, right? Low repair costs, downtime not a big deal, low risk, no safety, no E8 environmental health and safety risk, stuff like that, right? Spare parts and repair plans. We want to make sure that that they're readily available, right? If you have something that's on run to failure scheduling, when it fails, make sure you have it to replace it, right? Depending on the criticality, you don't want to be waiting around 3 weeks to put something in that you've decided that you want to let fail. Cost analysis, right? We talked about that. What's the association? What's the downtime cost? What's the people cost to fool with the thing, and make your decisions there. And then risk management, of course, as we talked about the different high probability and low probability functions there, so we can understand where those hazards are, and if we should be running to failure or having more of a proactive approach. Okay, integrating PM and condition-based maintenance into reliability-centered maintenance methodology. Amissa, you will be sending this out to everybody, right? This recording?
Mm-hmm.
Okay,
Yep.
cool. I just want to make sure. I just want to make sure I'm not going too fast or anything like that. All right. So the symbiosis of preventive maintenance and condition-based maintenance. If you see there, that's Upkeep. That's our edge platform. That's our sensors and analytics tool that we have that connects directly to Upkeep. So if we're integrating preventive maintenance with condition-based maintenance, it involves leveraging strengths of both strategies and creates comprehensive maintenance plans that maximize equipment reliability, right? So preventive maintenance side is best suited for components with failure modes are well understood and can be effectively prevented through regular maintenance. That stems a lot from the failure modes and effects analysis. And if you're not doing that in the design phase, do a watered down failure modes and effects analysis on the machines you do have, at least for the critical systems of those machines or systems, so that you can understand where your preventive maintenance tasks need to be targeted. Again, we talked about that, belts, filters, lubricants, stuff like that. Condition maintenance is ideal for components where failure mode is less understood and where real-time monitoring can provide early warning signs of failure. So you might know the failure modes of your condition-based maintenance monitored machines, but you may want to have that delta of warning time. That's really what condition-based maintenance is about warning time. It's about detecting a failure mode and then having it planned to go down, as opposed to letting that failure plan your downtime for you. What's this? Maria said, should agencies identify their critical and non-critical assets first before proceeding with it? Yeah, of course. Yes, you can do a critical and non-critical assessment of your assets, regardless if you're going to do failure modes and effects analysis. You should have that those priorities and criticality in your CMMS, right? So you know, and everybody at the organization knows what's important and what's not important. Because what you will find, and everybody on here will know exactly what I mean, operations, if you don't have these things defined, operations will tell you that everything's a priority. And if everything's a priority, nothing is a priority. So it's so good to bring operations into the mix, safety, all these people, get them together and say, hey, let's set a criticality matrix for our machines so that when downtime does occur, we all know what the priority is and we're not fighting over what we should be doing first or last. Good question. Steps for integration. So assessments of critical functions. There, we just talked about that, Maria. There you go. Identify the critical functions of the equipment or systems, determine which functions are essential to safe and efficient operation. Prioritize them. We can substitute that for even assets. The entire asset is itself, same thing. With your failure modes, right? Your failure modes analysis. So you understand what is a potential failure, what's the risk associated. Then we select our, this is just a recap. We select our maintenance strategy to best suit those risks and failure modes. We implement them. We develop maintenance schedules, procedures, monitoring systems, all align with the selected strategy. So the maintenance teams are trained in both of these. Like, when we mean by that, they don't have to be experts in vibration analysis, but they do need to understand why it's there, what it's monitoring, and what are the risks associated with it, either it not functioning correctly or if it does find an anomaly, right? So we should know what certain vibration sensors, how they should be mounted on machines, right? Are they epoxied? Are they on a sticky thing? Are they magnetic, right? So we have to understand all those things for the application so that we can make sure that our condition-based maintenance techniques are right and they're giving us the right information. And then continuous improvement, that goes without saying. We want all of the things that we do to have to be some sort of feedback loop to then make better and better and better decisions as we move through our maintenance journey. The benefits of integration, of course, it's a little redundant, right? Enhanced reliability. What we mean by that is you will be better maintaining the machine to its design characteristics, which in turn will allow the machine to be as reliable as it is designed, which is the most reliable it will be unless you change the design. Maintenance costs. It's a proven track record with the appropriate planning and scheduling, which is huge, and the appropriate tasks and checklists that are pointed at failure modes, integrated with preventive maintenance and condition maintenance, will optimize your cost, no doubt. You will start to see lower total cost of ownership. You'll start to see your replacement asset value numbers hitting the right percentages, all those things. And then, of course, data-driven decision-making. At Upkeep, all of our condition-based maintenance strategies in the system all feed to very, very in-depth dashboards that you can derive a lot of information from. So if you're interested in those things, please let us know. All right, closing thoughts. Maintenance optimization is a vital aspect of effective asset management, ensuring that equipment operates reliably and efficiently while minimizing downtime and maintenance costs. It goes without saying, right? If we do all the right things proactively, we're probably going to get a better result at the end, right? Mike's got some bad internet connections. Me too, man. We're getting a hurricane coming up through Florida, and it's just pouring down rain here. Integrated preventive maintenance, by understanding failure modes, right? We understand failure modes in FMEA, implementing optimized strategies so that we can leverage reliability center maintenance, our preventive maintenance strategy, and our condition-based strategy to improve our asset performance and the costs associated with it, right? Integrating preventive and condition-based maintenance and the reliability center maintenance methodology provides a comprehensive approach to maximize equipment reliability. So the big thing here is by leveraging your systems and by leveraging the data that you're putting into these systems, you're going to be informed, right? You're going to have better optics and line of sight into where things are eating your lunch and taking your time and affecting the organization negatively. You will have a much better opportunity to understand those things, and you will also have that information, that historian to then go to the bigger business and make changes and provide details into why we should be doing better things and moving forward. So, all right. Thank you.
All right. I will mention, I posted a link in the chat to one of our website pages where you can download a more detailed guide on this subject that we created. So it'll give you a little bit more detailed guidance and go over some of the things we talked about here in a little more detail if you want it. You can download it there. Also, if you're not already an Upkeep customer, you can sign up for a free trial if you want to give it a shot. And we also have experts on staff that if you're trying to do a preventative maintenance program, you're trying to come up with the best maintenance strategy for you, like we can help support you in that. So just reach out to us, if you have questions, especially if you're already a customer and you're needing help with that, like please do reach out to us and we can help you.
Yeah. The big thing that we find is that people have a very basic preventive maintenance strategy. Where they lack is the detail of what should be conducted in each preventive maintenance task. And it's likely that it's their time constraints. They don't have time with the equipment to really assess it, which I understand. And where you can get around that is trying to get machine diagrams and blueprints and PIDs. And then you can start to look at those things and build out a more theorized service. And then when you do touch the machine, you can then go against that document and then modify it to what is actually there and what's real and what's wearing and all that other stuff. So I used to do that a lot. If I couldn't get a machine, I would use the drawings and look through them, find bearings, find belts, look at the materials things are made out of. If you got steel bolted to aluminum in the presence of moisture, you're going to get, bad corrosion between those two, and the aluminum's going to get all eaten up, right? So all of those things you can check out.
And we do have a few questions. I'm going to go back a little bit. Mohammed asked, no, it's okay. Mohammed asked a little bit ago, if the process is safety critical, what strategy of maintenance would be applicable?
So safety as in machine safety, human safety, environmental safety. I'm assuming it's all of those things. It's best to have a person, unless it's in a very unsafe environment, you could monitor with a sensor. But for highly critical things, I like to make sure that the inspection scheduling falls within some sort of compliance or criteria. I normally get that from the safety and quality department or senior leadership, so that the decision is made above me, and then I tailor a strategy around that, right? So I love putting people's eyes and a human on highly critical safety related items. But if it's in an inaccessible area, it's best to monitor it remotely and then set up a schedule to where a person does view it every once in a while, so that you're making sure that sensor and all those things are doing what they're supposed to be doing.
Okay. All right. Joseph asked, How can ERP and CBM systems support predictive maintenance strategies?
So condition-based maintenance is, I just don't like the word predictive. Condition-based maintenance is essentially predictive maintenance. Predictive is a term that people have coined to say that they can predict when something is going to fail. When you leverage condition-based maintenance, you're using the machine's current condition to assess when things could be a problem, and then making a strategy or a plan to mitigate that risk or eliminate it before the failure occurs. ERP, your enterprise resource planning, I'm sure some of them have integrations with condition-based sensors and things like that. I'm not sure. I know if you have CMMS, most CMMSs will connect to your ERP, let the business use the ERP, and let the maintenance team use the CMMS with sensor data connected to that, if that's what you choose.
I think we're being called out here, Brian. Maybe you can answer this question. What does Upkeep bring to the table that other programs do not?
Sure. So it's very true. A lot of CMMSs they have a lot of the same functionality, and a lot of the nuance that people like is very small, minor things amongst them. But what Upkeep has I would say amongst our 5 real competitors is we have far, far more robust analytics. Most of our competitors have just basic like PMs closed versus opened and downtime, like all this nonsense, right? But Upkeep actually has analytics that can be totally customized to you. We can derive so much information. Our dashboards are far more robust, customizable. Another we have hundreds of different types of technologies that can be linked to Upkeep to provide more insights and things like that. So, and then, the last thing is our support structure. Upkeep has more CMRP certified people in the business than all of our initial, like our top 5 competitors. We actually have maintenance people on staff who help drive product innovation, who literally, like myself, I do it twice a week, help customers solve problems that are not just associated with CMMS. So when you purchase Upkeep, you're purchasing industry professional insights as well. And I don't know if you're familiar with the ambassador program that we have, but I set that up, and that is 10 super heavy hitter maintenance and reliability professionals, including George Williams, JD Solomon, Bob Latino. All of those people have a hand in the way in which we do things. So those are the main things.
Good answer, Brian. Let's see here. We do have a couple more questions. So regarding maintenance requirement analysis, what's the role of good selection of the maintenance strategy?
Read that again.
Yeah, let's see. I'll read it again. Regarding maintenance requirement analysis. So maybe like FMEA. What's the role of good selection of the maintenance strategy?
I guess I don't understand. They're the same thing.
Mm-hmm.
Like
maybe it's like doing FMEA is what gives you the guidance to know what the maintenance strategy should be.
Yeah. Because remember, appropriate preventive maintenance strategies are directed at a failure mode, right? I think there's an understanding that needs to be understood, which is you don't just do PMs to do PMs. You do PMs to address potential failures and risks, so that those things are kept in the spotlight, so that you can keep abreast with them and replace parts and inspect things and do them ahead of time. That's the goal. The goal is not just to do maintenance, right? The goal is to do maintenance that is directed at a failure mode, and failure modes are uncovered during failure modes and effects analysis, if that makes sense.
Yes. Yeah. Okay. Since the equipment will be broken down into sub-elements, should we create an asset hierarchy for different types of equipment?
Yeah. Yes. You can break into your parent and child relationships of your assets and break down the subcomponents. It all depends on how in-depth you want to get with it. they're looking at your risk priority number with an asset broken down into different components. Some of the components might be such low risk that you might not need to break them down into their own asset category or child asset, right? So you really just need to let the understanding of the asset drive the way you do it. What I would say is this: break the criticality of your assets, whether it's parent, child, whatever, down only as far as is necessary to get what you want. Don't just make it super, super complicated to be super complicated, because you're going to hate yourself in the end, and your team's going to hate digging through all those assets and sub assets to create a work order. So only go as in depth as is needed for the desired outcome.
Okay. And there's a question I think I can answer, and then you can add in if I missed something, Brian. But Mohammed said, integration of PM and CBM is RCM. So I think, yeah, exactly. RCM is the methodology.
Yes.
And using failure modes and effects analysis with RCM is going to give you the guidance to know if you need to do preventative maintenance on certain things, if you need to do condition-based maintenance. It's the methodology. RCM is the methodology framework that helps you determine the maintenance strategies that's going to be best for you.
Right.
RCM is like the overarching thing.
That's right. I was going to say RCM is like the umbrella for which all these things kind of fall neatly underneath of.
Yeah. All right. How do you perform a life cycle analysis on assets that are operating with parts from a boneyard?
Well, I would take you would have to know the initial install dates and time, things like that. But I would just use I don't normally like to say this, but I would use your mean time between failure to understand more of those components those parts you're using from a boneyard, right? Because you might be able to build enough data to say, hey, we're using all these boneyard recycled cannibalized parts, and we're not getting the expected life out of an operating condition out of these machines. If we bought some new parts, it's possible that reliability would be increased. And what I would say to do that would be try to get permission to buy one new part that you've been using as a boneyard part and measure its mean time between failure, and then leverage that data to then go to leadership and say, hey, look, we've been using boneyard parts, and yeah, they are cheaper or nothing, but we're not getting the availability out of the machine that's productive. I went and bought one part, it cost X, but it increased the availability of the machine over this amount of time, which accounts for the downtime and the potential lower cost of that used part. If that makes sense.
Okay. And then Joseph said, how can you effectively measure the performance of your CMMS in everyday maintenance problem solving framework?
Well, it just depends on the metrics that you're looking at. And remember, everything in your CMS starts at the input of the data on a work order or of a sensor, right? So if you're inherently putting in poor information or have poor hierarchy, poor criticality in your CMMS, the data you're getting is not going to mean anything to you. So I would say the first thing is to make sure that the data that's being put in on each work order is what you want. You have to scrub that data and understand it if it's right or wrong. The second thing is you have to pick certain KPIs that are meaningful to your business. What's meaningful? Is it just downtime, or is it the productivity of your technicians? Is it how much work is generated from each preventive maintenance task? Is it how much defect elimination that you've achieved by changing the design or having a condition-based monitoring strategy? So you have to understand what you want before you can measure it.
Yeah, that's what I was going to say is knowing, because every team is a little bit different on what kind of goals they're going to have or performance measures. The assets are different, like things are different. So I think you have, as a team, have to decide for your team and for your organization what are important metrics to measure, and then make sure that when you're creating your work orders and your preventative maintenance program, that all of that information is being input through there so you can actually track that. And just a little plug for next month, we're actually going to be doing a webinar on how to identify like KPIs and performance measurements for maintenance. So we will be talking about that next month. When you guys get the webinar invite to that, if you're interested in learning how to identify those, we are talking about that next month.
Yeah. So like an example, when I was leading as a maintenance manager and director of maintenance and reliability, I was super interested in eliminating maintenance tasks. I did not just want to do maintenance. I didn't want to have busy work for people, right? So I was very, very interested in the corrective based on my preventive maintenance tasks that were faced at a failure mode. I was very interested in how much corrective work was generated from those tasks. So meaning my guy goes and does a PM. The PM precisely says what he should be looking for. He finds a problem. We generate a corrective work order off that task. I used to measure that percentage and count so that I could start to see what are we eliminating. So then if we eliminate that problem, I know that I don't have, that task can either go away altogether or it can be pushed out further. So I'm not just doing maintenance all the time on the same stuff. I'm literally using the preventive maintenance strategies that I've developed to then eliminate doing maintenance and eliminating risk altogether, not just doing maintenance to do maintenance.
Yeah. We have a couple more questions. I think we have time for them. How does Upkeep help in identifying the total cost of ownership of an asset?
Yeah, so Upkeep has, and none of our competitors have this, which is the replacement asset value function. So when you buy a machine or you know the value of a machine in its current state, you can put that in this part of Upkeep. And then as you generate work orders, man hours, spare parts, all that stuff, downtime, whatever, against that asset, that does a replacement asset calculation and starts to show you how much money you're spending against the value of that machine, right? So if you depreciate machines over a 7-year period, you know at year 2 the machine's worth X and you've got this much money in maintenance tied up in the machine, you can start to understand whether, hey, next year we're not maintaining this thing anymore, we're going to replace it. Or, hey, we're maintaining this pretty efficiently. We can leave this thing alone and we don't have to buy a new one, and we understand the life cycle costs a little better. But the replacement asset value function in Upkeep is super, super valuable. We also have a depreciation schedule in there as well, and warranties.
Okay. And then a clarification of, they were asking which comes first, requirement analysis or the selection of the maintenance strategy. So the analysis comes first, and then you choose your strategy based on what you find in your analysis.
That's right. Understand the machine, understand the ways it can fail and the risk and the detectability and the likelihood of those failures. Then you build a preventive strategy or a condition-based strategy to address those failures.
Yeah. And then last question is it possible to do FMEA for failure during normal operation?
So you're saying, like, just
like if I'm guessing if the equipment's operating, I think that's
well. So a lot of times when a machine fails, leadership will be like, I want a root cause analysis done on this machine, right? And most of the time, the maintenance department goes, we're going to do a 5 whys. 5 whys. Why did this? Okay, why? That's not really that, right? That's a very shallow understanding of what happened. I think that's what he means. Like, could you perform failure modes and effects analysis when a failure occurs during normal operation? The answer is yes. But you would have to stop if you don't have the drawings or any kind of historical data or anything like that, or you don't know the failure modes, you would have to assess the machine. So you're probably better off to do a root cause, like a pretty good root cause analysis to understand the machine, and then go, and once you have all the information about the machine broken down into subsets, all the stuff we talked about in the failure modes and effects analysis framework, then you could do it, and then you'd have it for the next potential, right? And hopefully, if you do it right, the failure that occurred during operation might not happen again because you've addressed it.
Yeah. All right. Well, everyone, we're heading up on time, and I believe we got to all the questions. If you are an Upkeep customer, like I said, and you need help, coming up with some maintenance strategies, or there's something you need help with, you can email us and we'll get you connected to the resources you need. And also, if you're not a customer and you want to try Upkeep, you can email us, or you can click on the link I put in this chat to try a free trial of Upkeep. But we really appreciate you guys being here. Look out for our webinar invitation for next month's webinar, which will be about creating meaningful maintenance metrics and KPIs and how to do that. But we really appreciate you all being here, and have a good rest of your Wednesday.
Thank you very much.
Bye.